Our next presenter, Arup from PagerDuty, formerly of Amazon and Netflix, right?
Yep.
Now at PagerDuty, which we all love to hate because they wake us up, but they do wake us up when things are broken. So thank you.
All right, thanks, Bill. Which button? You tell me.
Oh, yeah.
No, that. Once more.
We've only done this 6 times, y'all.
There we go. Good morning, folks. All right, come on. Good morning.
Good morning.
Thank you. Like Bill said, my name's Arup Chakrabarti. Last name is phonetic. First, I want to thank all the organizers at DevOpsDays Chicago. You guys have just done a phenomenal job. I had a great time yesterday talking to folks during the open spaces and had too good of a time last night. And so we'll see how quickly I can get through this presentation. The title of my talk today is Who Watches the Watchmen? If you don't know the reference, it's a reference to the 1985 graphic novel about a group of vigilante heroes that look over the world, and everyone always asks, well, who watches over these guys? Who watches over the Watchmen? And I kind of think of PagerDuty in a similar way when we think about our monitoring infrastructure. I have my Twitter and my email address up here, and I'm going to now turn off my phone so I do not respond to your angry tweets during the presentation. If you have any feedback or questions throughout the presentation, feel free to tweet at me directly or shoot me an email. Really quickly, what is PagerDuty? Actually, quick show of hands, how many of you guys have heard of PagerDuty before? Wow, that is much more than I thought it was going to be. Okay, so really quickly, we provide alert and incident tracking, on-call management tools, on-call scheduling. We integrate with your existing monitoring tools, and really our goal is to alert the right person every time. This is a very technical diagram of how PagerDuty works. Basically, stuff happens on the left, then magic, and then the right person's notified. So why do we at PagerDuty care about monitoring? This is our outgoing traffic from the AWS US East 1 outage earlier this month. If you're looking at those lines, you might not be able to see them. TLDR, our traffic ramps up by about 3 to 4x in under 4 minutes. And so our customers, you guys, care very much about monitoring and alerting. Therefore, we also have to care very much about monitoring and alerting. So for the talk today, I'm going to cover a couple things. What is PagerDuty? I already covered that. Our philosophies towards monitoring. Tools that we actually use. I'll go into actual specifics around how we actually set them up as well. How we think about security as monitoring, distributed systems monitoring, dependency monitoring, and basically how we do all this in Chef and effectively cheat. And then last, we'll cover how we validate that our alerts are actually working, and then with some time left, we'll do some Q&A. Quick disclaimer, I work with some really smart people, and I'm very lucky at PagerDuty to work with people that are much smarter than I am. And I'm up here talking about a lot of these things, but I want to make sure that it's very clear. I did not come up with everything that I'm going to be talking about today. I did not build everything, and so I want to make sure that I give appropriate credit to the folks that I work with. Another thing is that the slides will be posted, so if you miss a note or if you have a question about something or follow, I will post them online, so don't worry if you miss a note. So let's jump into our philosophies. Very quickly, the reason I call them philosophies is that these are not hard, steadfast rules. These are things that kind of help guide us, but every now and then we do have to bend them. That's why I don't call them rules. First off, use the right tool. We just talked about in the previous talk that the same tool is not the right thing for every single application. If you need time series data versus event data, you need to use 2 separate tools for monitoring those things. Avoid single host monitoring. Basically, anything that is running on a single box, assume it's brittle. Assume it's going to break, assume it's going to go away, and always assume it's going to happen at the worst and most inopportune time. Alert on what customers care about. This is something that I see a lot of guys make mistakes on, where they'll alert on every single error or fatal or something in their logs. And realistically, if Nginx is going to do a retry for you and the customer never notices it, maybe it's not worth alerting on. Now, when I say customer, that's going to change depending on where you are in the organization, right? So if you're working on more customer-facing end-user type thing, you're going to want to monitor latency, availability, things that your end users are going to be seeing. If you're on more of a operations internal focus team, you might actually care about the CPU on your Cassandra cluster because you know that's going to affect your other engineering teams that are your customers. Alert on expected values, and this goes on for both high and low. So obviously if CPU is pegged at 100%, that's bad. We know that. But if it's bottomed out at 0%, there might be something going amok there too. That's a mistake that I see a lot of folks make where they forget to alert on low thresholds. Make it self-service. One of the things that at PagerDuty, our operations engineering team has learned is that if you make something more self-service, more people are going to use it. Now, they may use it in very creative ways that you never thought was possible, and that might irritate you or frustrate you sometimes, but that's okay. If you can make it self-service, at least you can get people to start using it and learn from their patterns. And then lastly, you have to validate that the alerts work. Now, ideally, we could do this automatically and just kind of keep running this, but this is actually really hard, right? So every now and then, you might have to go in manually and actually check that your alerts are still working. There's a variety of ways you can do this, and we'll actually be covering one of the methods that we use later in this talk. So to jump into the specific tools, we use New Relic. For those of you who aren't familiar with New Relic, it's an application performance management framework that we use. And it gives you graphs. You know, this is, I don't know, response time, so that looks pretty bad, 300 milliseconds. Gives you more graphs. App instance restarts by host, that sounds important. Oh, and stack lines, you know, even more graphs. This is wall clock time. Yeah, I know exactly what that means. Oh, and bars, so you can get both line graphs and bar graphs, you know, nicely laid out. This is response time and throughput. And reports, fantastic. We get numbers that we can screenshot and show up presentations like this and give to our business guys. And more reports, and we get all these tiny little numbers and uptime metrics and what else? I don't even know what that means. So my opinion on APMs in general, they're great for small environments, they're great for new stacks, and the reason is that they give you a lot of information, right? You install the single agent and they'll start just collecting all these gobs of data for you, and that can be really helpful, especially early on when you don't really know what you need to look at yet, right? And so when you first start a business, start a stack or something, you might not actually know what your critical metrics are yet, and setting up an APM is a super easy way to get at least some set of metrics that you can start poking at. They're helpful for tracing transactions if you have that turned on. Because it's installed on multiple, probably your app servers and your database server, you can try to figure out, okay, how long did it take for this 300 millisecond request to render, and then figure out where is it spending all of its time. And like I said, it gives you a lot of data. Cons, they can be overly prescriptive. As your stack grows in complexity or your business matures, you're going to start to learn what you need to care about. And a lot of times these APMs, you know, they're really much a one-purpose solution, and they will be overly prescriptive. So a lot of times you can't actually get the data that you know you actually want to get. They can be hard to tune and customize sometimes as well. That can be a frustration as well. And then, you know, I list it as a con as well. It gives a lot of data. Yeah, that's another problem where if you have too much data, you end up with that sort of analysis paralysis problem where you're just kind of going to keep looking at these things. We also use StatsD and Datadog. Datadog guys are here. I highly encourage you guys to chat them up. We are huge fans of the service. Basically, StatsD is the metrics client, and we use Datadog as our backend. Super easy to use. Basically, these are the 3 example lines of code for gauges, counters, and histograms to just start measuring things in your applications and services. And any engineer can pretty quickly figure out how to slap these in there and you can start measuring things. You can set up custom alerts. Again, like I was saying earlier, self-service. All of our engineering teams go in and they can set up their own alerts. They have really nice custom notifications as well. There's a PagerDuty integration. They support email. We're big users of their HipChat integration. So this is me shooting a note about the number of rows modified from our database into our operations chat room. Pros, very customizable. You can basically get metrics on anything that you want, anything that you care about, you can get it. Because of that, it can change as you grow. As you mature as a business, as your stack changes, you can update those metrics to reflect what you now care about. And again, the self-service piece, this has been great for encouraging all of our engineering teams to actually be more metrics driven and actually shove stuff into there. Cons, I'm a firm believer that you need to have configuration management set up before you can start down this path. There are ways to install these agents and everything before you have configuration management in place. I think it's a lot harder, so if you have something in place already, it's a lot easier to install these agents. It was harder to also ramp teams up. Basically, we had to give everyone a primer on the StatsD client and what it meant, but it wasn't too bad. We basically spent half a day with all the engineers and said, here's exactly what these different metrics mean, and here's how you manipulate them. Sumo Logic, it's a logging service, and basically we ship all of our critical app logs, and then engineers set up alerts on patterns. So an example would be, let's say one of our endpoints had too many 500s in the last 10 minutes, shoot out an email and trigger an alert from that. It's somewhat self-service, so the alerting piece is self-service, but the initial setup is something that's done in Chef by our operations engineering team. One problem with it is that it's actually really hard to use for real-time debugging, and the reason for that is that there's a propagation delay from the logs from your local servers shooting out to Sumo Logic. So basically, for real-time debugging, every now and then we have to do sort of a distributed tail, unfortunately. And of course, question that I always get, does PagerDuty use PagerDuty? Yes, we do. We do dog food, or I actually prefer to say we drink our own champagne. We do, I don't like the term dog food. We drink our own champagne. We are constantly, we are our own internal customers of the product. So, some of the pain points that I hear about PagerDuty all the time, trust me, we know about it. And it's something that we have plans on addressing. We also have some simple external monitoring, and we did some interesting work here where we use these tools called Wormly and Monitis, I don't know. I never know how to say it. It sounds like a disease to me, but these are very simple tools, and we use them as a backup alerting mechanism just in case our other alerting tools go down for whatever reason. They're very naive in their health checks. Basically what they do is they check for 200s and expected text on a page. And so what we had to do, we actually had to make a smarter health check. We had to build out basically an external page that these simple health check can ping to actually make it smarter. So how did we do that? Basically, we created an external health check page which lightly touches each of our services internally, and the services then return back a status into that health check page. So if for whatever reason the service times out or there's some sort of error, it'll report that into that external health check page, and it gives back an expected value. So basically, we're always expecting okay to show up. And if there's a non-expected value, there's either a timeout or it's a 200, but we give back a response saying, no, stuff's broken. I have to try to not curse. We then alert on the non-expected value. Security monitoring. This is something at PagerDuty that we've been pretty aggressive about over the last year and a half. And really, why do we do security monitoring? One reason is that audits are tedious, right? I think all of us have been through those quarterly, yearly, every 5-year audits, and it's a nightmare, right? Because you're having to go through this whole list of changes and all these other docs, and who knows if it's up to date or not. And really, it's just frustrating to do. No engineer actually wants to do these things. So we actually take this approach that we actually just constantly are scanning our infrastructure and looking for security issues. And really to kind of take the idea that, from a production issue happening, the earlier you can catch it, it's usually easier to fix, right? So if an engineer accidentally opens up a port on one of our firewalls, it's much easier for us to alert on it in real time and then fix it and politely tell that engineer or ask why they did that. Some of the tools we use here, intrusion detection via OSSec. It's an open source IDS solution. Basically what it does is it goes through and monitors critical logs like your auth log and looks for patterns, and it also can check some directories. So if an attacker gets onto one of your boxes, manipulates the user bin, you can actually alert on that. We do continuous port scanning against our entire infrastructure. So again, going back to the firewall example, if a piece of our infrastructure is accessible on a port that we did not whitelist, we actually get alerted on that, and then we can go in and fix that. And we do this just via simple nmap. And then another example of our security monitoring, we're scraping IPsec data. So we encrypt all of our cross-WAN traffic via IPsec. And so we scrape that data and then shove it into Datadog, and we can actually alert on that as well. So let's say the percentage of traffic being encrypted drops down all of a sudden, we can actually alert on that. Distributed systems. Distributed systems are hard because really the single host does not matter anymore. And so when we think about distributed systems alerting, really it's about alerting on cluster level metrics. You don't care about single boxes anymore. So ideas here is you alert on overall number of 500s, not number of 500s in a single log file. You care about the percentage of nodes that are down, not just one node being down. You care about overall latency. If one box is misbehaving, you might not care about it, or you might want to just yank it automatically as long as the overall stack is still behaving properly. And so the sort of topology that we think about at PagerDuty we have a very highly distributed architecture across multiple data centers, is that basically we try to funnel all of our systems to go through that highly available monitoring system and then use that to plug into PagerDuty. We try to actually avoid going into PagerDuty directly from our existing servers. And this applies to, the same model applies to actually our services as well. So the services that are then distributed on top of the infrastructure, again, goes through this sort of central choke point with the monitoring system. Every now and then we will actually bypass it and go into PagerDuty, but we try to avoid that actually, and because it's hard to get those metrics and do forensics when the service is just spitting out alerts directly. Dependency monitoring, stuff that you do not control. Quick raise of hands. How many of you guys use another SaaS solution in your infrastructure? Like PagerDuty, for example. Okay, For our operations team, it's a nightmare, right? We have all these external dependencies that we rely on that, we swiped a credit card and we place a lot of trust in them to keep running, but they go down, right? So we have things like DNS monitoring tools and logging tools that we're using. So how do you monitor these guys? Well, I don't really have great solutions here. So I do this manually every now and then for DNS, create and delete records. We actually do that almost daily, so we actually have some level of monitoring on it. For our monitoring tools, we'll do basic pings, make sure they're still up. For our logging, once a month I go in and I validate, yep, those critical logs from a sampling of 10 boxes are still being shipped. Again, not that great because I have to do this manually. Status pages are getting better. This is something that I've been really happy about over the last couple of years, is seeing the transparency that companies are giving with their internal outages and saying, yep, we're having an outage and we're on top of it or we're not on top of it. But it's nice to see that. On our software side at PagerDuty, we have other dependencies. We have email, SMS, phone, and push notifications. That's the way we get a hold of folks. But we have software dependencies there. We use third-party providers for all of these things. So how do we monitor these guys? And really, this is what keeps us up at night. So I'm going to jump into a quick story. Basically, we had our primary SMS provider was quote unquote up, and customers weren't getting their SMSs. They had configured their alerts to send to them via SMS, and they weren't getting them. And we found out in the worst way possible, which is the customer had to call us and say, dudes, what's going on? And our support team appropriately escalated the issue. And honestly, we started going back. We're figuring out why didn't we catch this? And really what happened was the provider, our SMS provider, was actually sending things out, but T-Mobile prepaid, very specifically, T-Mobile prepaid was not passing our shortcode through. For whatever reason, they blocked it. Okay, so we built out what we call our end-to-end testing framework. Or as we call it, how to abuse unlimited messaging plans. One of the engineers, Ashwin at PagerDuty, built this out. Basically, every minute we send an SMS alert, every SMS provider we use, and we poll against the main carriers, Verizon, AT&T, T-Mobile, and Sprint, and we measure response times. This is our device lab. It looks nicer now. It's like nice on a wall and everything. But I like this. The T-shirt, the empty desk. It's good. So I have some stats, and I didn't want to give out the carrier names, but I was drunkenly convinced to at least color code these guys. So you can. So I'm not saying it. You can blame one of my coworkers for why that's up there now. I'll just tell you, if you're on a certain yellow carrier, you might want to rethink it. What's interesting also about the response times on these guys is that they're very spiky. It's somewhat periodic, but even through the day, we just notice spikes, and every now and then it'll spike up to 500 seconds. And that's absurd for us to think like, why is an SMS taking that long? But it's something that unfortunately isn't fully within our control, but at least we know about it. So when a customer does call in and say, hey, I noticed my SMS took an extra minute or two to get to me, we can actually see that now. And we actually do alert on these things. So when carriers are having problems, we can at least post on our status page that, hey, we know T-Mobile's having an issue. We're working with our third-party providers to figure it out. Lastly, how are we cheating using Chef? So all of our agents, for all of our monitoring agents, we install all of this via Chef. So basically, any server that gets spun up, it gets all of our main agents installed. With Datadog, we actually set up the stupid alerts as well. And by stupid alerts, I mean CPU alerts, disk space utilization, memory utilization, and load. These are things that we just set up catastrophic alerts on, and basically every single box that gets spun up in our infrastructure has these easy alerts already in place. Our backup alerting systems are not automated. That's somewhat on purpose, is that the idea that we want to have that somewhat decoupled. The ideas we have there is just have like an offline batch job that runs, say, once a day or once a week to keep those things up to date. And then, and also our cluster alerts setup are not automated yet either. So that's something that our individual engineering teams go in and they set up their cluster level alerts because those aren't fully automated yet. How do we validate this? We have something at PagerDuty that we call Failure Friday. It's very much inspired by the Netflix Simian Army idea. And basically, we just go in and we attack our own services. One of the engineers, Doug, where are you, Doug? There he is. Doug has talked about this extensively. If you have any questions about that, please talk to Doug about this after the talk. But basically, we just go in and we knock shit over. And that's the point. We leave all the alerts up and running. We break stuff, we break processes, we break our network, we break our data centers as much as we can, and it's really with the intent of validating alerts and learning. That's why we do this once a week. And we've written about it, but like I said, if you have any questions about it, feel free to follow up with Doug afterwards. What have we learned from Failure Friday? One, these are just a couple of things. One was the process monitoring was commingled with the process running. So the service dies, and voila, the monitoring around the service also dies. And ta-da, you never find out about it until it dies on every single box. So we set up better external monitoring. Another interesting thing was we had only local host checks on the service. So of course, whether you like it or not, Amazon will take away your servers, and all of a sudden our server's gone, and surprise, we didn't know about it because the local host was what was running the monitoring. Another thing was that alerts require outbound network connections. So we go in and we blocked outbound network connections. Again, surprise, because no data is being pushed into our monitoring system, it doesn't alert. So the way we fix that is we then set up alerts on null data effectively. Thank you very much for listening to me today, folks. We are hiring at PagerDuty. If you're interested in working on thundering herd problems like 3x traffic in under 4 minutes, if you're interested in working with the best operations engineering team under the sun, please come talk to me or Doug. We'll be around today and this evening. So with that, I will open it up to some Q&A.
Questions?
So you use a lot of SaaS solutions,
Yep.
As you talked about earlier, and I'm assuming all of those cost a certain amount of money. So how do you kind of keep your kind of cost structure in control and continue to provide the value that you'd like to your consumers without kind of like overburdening them with cost?
So basically, how are we keeping cost control? Basically, how are we keeping our SaaS solutions under a reasonable number?
Yes.
Really, I wish I had a better answer for this. I have to do the invoicing for it every month, so when I see the number go up too high, I kind of question that and figure out why is it going up too high. Obviously, we try to be resourceful. We don't want to waste money on our solutions. We actually went through probably about a couple months ago. We actually went through and did an audit of what are all the agents that are running on all of our boxes, and we actually rip out tools periodically. We try to keep it down to a minimum, but at the same time, we also want to provide redundancy for ourselves for when one of our services do go down. So it's a tough balance. We basically just take the approach that keep the agents to a bare minimum and have one backup.
Have you decided to not go forward with features because the services you would need to support them, would spike the cost?
No, no. At this point, PagerDuty, we're still growing rapidly, and it's something that, for us, the pace of product features and releases that we want to keep doing, we want to make sure that cost isn't a blocker. Now, obviously, if something's going to cost us $1 billion, we're not going to do it, but right now, it just hasn't been that big of a concern because our growth has been, thankfully, knock on wood, big enough.
Question back here.
So I'll ask you about PagerDuty. What are the internal escalation patterns at PagerDuty for alerts?
Oh, that's a good question. So the way we have our on-calls, the question was, what are the internal escalation policies at PagerDuty? The way we have all of our on-call schedule set up is basically each and every engineering team has their own on-call. So all of our development teams, operations teams have their own on-call schedules. And basically the common pattern is we have a primary and a secondary, and then we keep the team's manager on tertiary duty just because they should get paged as well. And that's effectively it. We used to have our CTO at the end of the escalation path for each team, but again, as we've grown as a company, it wasn't scaling, so we had to push that farther down the chain. So usually, for most teams, it's primary, secondary, and then the manager is the tertiary.
Other questions?
If you wanted to see how I can hear it. All right, okay, we can do Mike.
As a consumer of PagerDuty, what would be some strategies that we can use to make sure that we're properly communicating with you guys, and how can we test that PagerDuty is functioning and that we can trust it and everything?
How can you, no, that's a good question. We do have an external status page. We're, I would say, very transparent with when we have problems, and if you look at our status page, you'll see that when we do have problems, we post to it. In terms of best practices around how to use PagerDuty, we do have stuff in our support docs, but basically what I always tell folks is take advantage of the deduping. That's one of the biggest things that mistakes I see a lot of customers make, is that they'll set up their services to trigger new alerts on every single email or every single API call, and basically you're just going to take your phone and you're going to throw it against the wall, and that's not going to help you. So take advantage of the deduping, take advantage of maintenance modes also if you know you're going to be mucking around with stuff that's going to cause alerts that you can safely ignore. Those would be the two things that I always tell folks. But also check out our support docs. Actually have a fair amount in there for that as well.
One more question? Yes, no? All right, thanks, Arup. Thank you so much.
Thanks, guys.